This is the artificial intelligence voice of Lex Fridman narrating this pod-slice summary of the Lex Fridman podcast. Fridman and Cronin discuss potential life on other planets and the concept of alien intelligence. They discuss what may prevent us from making contact with or intersecting with such life due to the complexities with our ability to communicate. The conversation segues into Cronin's controversial assembly theory, suggesting that any object in the universe can be quantified by looking at the number of steps it took to create, and whether it was created through a process akin to evolution. They delve into the concept of an object, its finite nature, and how it maintains its distinguishability through a shared history or memory. Fridman quotes from the paper to define an object as something that persists over time and is breakable, and the set of constraints to construct it from elementary building blocks is quantifiable. Cronin elaborates on the assembly index, which measures complexity by breaking down an object in a lazy way and seeing how many minimal steps it took to recreate it. This, according to Cronin, gives a minimum bound on the complexity of an object. Originally, the mathematical explanation for this wasn't clear to Cronin, but his intuition told him it was important. His intuition was validated when a group of mathematicians provided a plausible physical explanation. They've developed methods to measure an assembly index. Firstly, by breaking down molecules and then applying it to language and mathematical theorems. They found that the computation becomes more difficult as the object gets larger. Using these principles, they have calculated the assembly index for emoji and photographs by breaking them down into pixels and then reconstructing them. They're exploring how to apply the same assembly principles to various scales and different kinds of data beyond compression. Finally, Cronin explains the four universes in assembly theory. Assembly universe, anything goes. Assembly possible, constrained by laws of physics. Assembly contingent, access to highly assembled object is given only after work has been done. And assembly observed, what we actually see and can reverse engineer. This highlights that any observed object must have been created through a causal process in physical reality. Fridman and Cronin continue their discussion about assembly theory, delving deeper into the concepts of selection and evolution. Cronin explains the importance of a shortest path to the survival and replication of molecules, an environment where molecules decompose over time. That those that can be built and reproduced in fewer steps have a higher chance of surviving. The shortest path evidently represents the minimal amount of information needed to propagate a particular motif over time. They dig deeper into the assembly equation, which seemingly quantifies the amount of selection necessary to produce certain objects. Some of the variables include the assembly index and the copy number, which reveals an interesting concept about complex objects. Such objects could be created randomly, but to confirm that they are not random, multiple identical objects need to be observed. Talking about selection, Cronin talks about how the environment itself is a factory, creating challenges that test the survival of objects, in this case molecules under different conditions. Not only that, these objects have a discovery and production time and have to be continuously remade to ensure their survival, leading to more robust selection and advanced evolution. They also touch upon the possible application of assembly theory in economics, city planning, and other complex nested systems. Their conversation carries implications for the understanding of the origin of life, the development of human culture and technology, biological evolution, and the nature of objects in the universe. They argue that the equation could even help us look for selection behavior happening elsewhere in the universe, looking for processes resulting in high copy number, complex objects, even if it's not viewed as life as we know it. The assembly equation, they posit, proves useful at both the lower end for looking at how, for example, hydrothermal vents can manufacture molecules, and at the higher end for identifying advanced selection as seen in biology. And their discussion. Fridman and Cronin explore the idea of using assembly theory to detect life on other planets. They talk about the creation of a life meter, a tool that measures the assembly index of molecules and identifies copies to look for complex organisms. The life meter would take a sample from the environment, for example, soil from Mars, and subject it to an electrostatic trap and monochromator Collecting volatiles that are then analyzed by the data from this could potentially indicate signs of life. The higher the molecular weight and number of fragments, the higher the assembly index, thereby suggesting complexity and potentially life. One element of assembly theory that Cronin articulates clearly is the balance of the assembly index and copy number, presenting them as being in tension with each other. And exploring this, they highlight that while unique, complex molecules could theoretically be formed randomly, the presence of exact copies of these molecules is what suggests a process of selection, a foundation of life. They refer to this as a structure in the random, asserting that ultimate randomness and ultimate complexity are indistinguishable until multiple copies are observed. Furthermore, they delve into the operationalization of the life meter, explaining how it would function in real time to analyze samples. It is designed to vacuum up a sample and analyze it either by measuring the weight and number of molecular fragments or by using infrared technology to count the number of bands. The more bands and fragments detected, the higher the assembly index, and the stronger the indication of life. Cronin does specify, however, that this suggestion of life only applies if the molecules have high complexity and are abundant. High abundant, complex molecules indicate a process of selection, a condition of life. To clarify, they examine the possible outcoming readings of the life meter, from Mia's demo indication of life to interesting possible signs of life to definitely alien intelligence, strong indication of complex organisms. In essence, their conversation revolves around harnessing chemistry and assembly theory to reframe our perspective of what constitutes life and how we can potentially detect it beyond Earth. Cronin and Fridman delve deeper into the practical application of assembly theory in the lab. They speak about various experiments they conducted using this framework. The sample of choice varied from Scotch whiskey to beer, owing to their molecular complexity that provides interesting subject matter. They discovered that even behaviors of whiskey could be indicative of its assembly index, with peaty whiskeys boasting a high assembly index due to their intricate blend of molecules. Cronin then addresses criticisms from evolutionary biologists who disapproved of their approach, declaring the origin of life as a solved problem. He states that this signaled to him that they were onto something pertinent, highlighting the gap between the origin of life and evolution. He further underscored that even physicists were interested, albeit slightly skeptical, regarding the idea. As Cronin notes, investigating differing liquids and substances can provide surprising insight into the molecular complexity of biological processes. From these experiments, they found that even substances like beer have high assembly index molecules, reminiscent of constructive life processes. Moving on to bigger scales, they began asking what assembly theory could mean for larger, more complex objects like organisms. Applying these principles to cell surfaces and morphologies, they continue to test these boundaries and explore new terrains. Interestingly, Cronin talks about using assembly theory to map the tree of life. By fingerprinting life forms based on their complex molecules, they can infer common origins, which essentially allows them to reverse engineer the tree. This presents an alternate approach to evolutionary biology, where traditional genetic sequencing or artistic renderings are used to map out phylogenies. Taking it even further, they discuss the potential for using assembly theory to not only map existing life, but unearth evidence of life forms no longer in existence, tapping into fossils where DNA may no longer exist. This could provide a new dimension of dating, exploring the history of molecular degradation and oxidation. They also note the possibility of using isotope arrangements to infer the age of a life form. These processes open up a plethora of exciting possibilities in understanding our evolutionary history and the complexity of life itself. Throughout this portion of the podcast, Lex Fridman and Lee Cronin continue their probing exploration of assembly theory. Cronin defends their approach against the critique from evolutionary biologists, demonstrating that assembly theory can be applied not only to biological life, but also to language, developing culture, and technological advancements. Cronin believes in the potential to determine the assembly indices of complex objects, like the human brain, which could exploit the morphological commonalities among varying species. He envisages an automatic way of discovering features potentially through machine learning and image recognition, creating observables that can be evaluated and measured. This concept opens doors to advancing the understanding of biological development, evolutionary history, and the complexity of living organisms. Cronin and Fridman further discuss the possibility of applying assembly theory to cultural evolution, text language, or images, and recognize that although not fully usable in its current form, the theory could evolve to fit these contexts. They suggest applying the theory to large language models to not only generate language, but also to understand the history and evolution of language production. Fridman draws a parallel between assembly theory and Kolmogorov complexity, which measures the length of the shortest computer program that outputs an object. However, Cronin warns against viewing through the lens of complexity theory, as it does not take causation into account. Hence, assembly theory presents a more comprehensive view of understanding life processes and evolution. He concludes that assembly theory is the foundation upon which factories of biological evolution or computing paradigms can be built. In summary, Cronin presents a defense of assembly theory against criticisms persisting in its wide-ranging applicability from biology to culture and its potential to revolutionize understanding of life, complexity, and evolution. Further elaborating on assembly theory, Lex Fridman and Lee Cronin investigate the depth of an object in time if it were treated without any external constraints, a capacity of the assembly principle that potentially could fuel revolutionary thinking in fields like drug discovery. Cronin suggests flipping the conventional approach of focusing on proteins in the process to looking at the evolutionary arc of the molecules that interact with these proteins over time. This way, instead of having to simulate all of chemistry, it is possible to build up the constraint space to define the area of focus for drug discovery strategically, fending off criticisms on the consideration of the varying probability of reactions in the assembly chain. Cronin redefines the concept of asymmetrical reactions. He argues against viewing it as a fixed activity, but rather as a transformation subject to constraints. The environmental and chemical composition are key factors that determine possible transformations and outcomes. Cronin's perspective challenges traditional views held by chemists and adds a layer of complexity to the understanding of our natural world from an assembly theory viewpoint. Fridman delves into the intricate process of conceptualizing, developing, and publishing scientific papers, with Cronin reflecting on his own prolific experience. The feedback process between authors, editors, and peer reviewers are a test of tenacity and conviction in one's work, with the potential for multiple rounds of modifications. Cronin reflects on his endeavor to present assembly theory at the highest level of scientific discourse. The intense scrutiny, the challenge in communication, and the continuous cycle of development and review. Cronin's passion for advancing assembly theory is evident as he recalls the complex process of bringing his paper to fruition. Despite multiple rejections and feedback that questioned the validity of his work, Cronin held firm, driven by a need for understanding rather than seeking glory. He saw value in the critical feedback and modified his work accordingly, not wishing to give up, but amazed and curious as to why people did not understand his perspective. Reflecting on his journey, Cronin highlights the emotional weight of conceptualizing and crafting a scientific paper, particularly when it contains groundbreaking or controversial ideas. During the podcast, Lee Cronin reflects on his educational journey, detailing his struggles with learning disorders during his early school years. Despite the challenges posed by his dyslexia and math difficulties, Cronin felt a deep underlying curiosity and an insatiable desire to understand things. His drive did not wane in the face of adversity, but was rather fueled by it, leading him to push his limits and find ways to achieve his goals. His proclivity for thinking from first principles is evident, and he credits his ability to think beyond conventional boundaries to being a source of his scientific accomplishments. Undeterred by initial failures, such as when he tried to build a laser at age 8, Cronin was always eager to learn, demonstrating resilience and determination, much needed characteristics for a scientist. His unconventional journey to becoming a research chemist exemplifies the traditional measures of academic success, like grades, can't quantify passion, curiosity, and a persistent drive for understanding. It serves as an inspirational message to young students facing academic struggles emphasizing that the will to not give up can sometimes override the traditional structures of measuring academic aptitude. Around the discussion of his education, the topic deviates to a deeper reflection on the nature of discourse and academia. Cronin finds value in criticism and views it as a powerful tool for refinement. His approach is to depersonalize criticism and focus it solely on ideas, intensifying its constructive potential. He believes that criticism done right can help us absorb the negative feedback, iterate it, and essentially convert it into a positive result. This viewpoint reflects his mechanism for progressing the assembly theory despite facing severe backlash and critique. Reflecting on the rejection and subsequent controversy of his paper on assembly theory, Cronin doesn't perceive all criticism to be detrimental. His mindset transforms criticisms into tools for enhancing his work. For him, the backlash it garnered was not a brand of failure, but a basis for discourse, an exchange of ideas, a viewpoint advocating for the importance of argumentation, criticism, and discourse in academia. Their engaging conversation dives deeper into the structure of time, its impact on free will, and its potential centrality to assembly theory, presenting a crossover between philosophy and science. This discussion reflects existing debates in the scientific community about the role of time in the natural world. Cronin explored the unconventional idea that time is a fundamental component for implementing the assembly theory, which further exemplifies his tendencies to challenge traditional boundaries of thought. Delving deeper into Cronin's pioneering assembly theory, the podcast transitions into a profound exploration of the size and nature of the universe and our place within it. Challenging conventional thought, Cronin believes that Earth is the largest place in the universe due to the vast combinatorial space grounded in its unique biological, evolutionary, and cultural processes. This perspective discourse aims to highlight the remarkable influence Earth has on shaping the universe through its unparalleled complexity. Examining the concept of alien life, Cronin assumes that life is likely emerging on other planets, but the probability that our combinatorial spaces overlap is slim due to high contingency associated with other life forms. He proposes we need to create versions of alien life in the lab because communicating with distinct bioarchitectures across combinatorial spaces is not a given. Conversations about a planet simulator come up, emphasizing its potential in helping recreate selection processes before modern biology existed, granting potential new avenues for life under different constraints. This adventurous endeavor provides a platform to explore the chemical constraints on life and to target more accurate search areas for life across the universe. In the journey of assembly theory discourse, Cronin introduces an argument that the universe is too vast to contain its future, hence asserting the fundamental nature of time. Segueing into discussions on free will, he explains his perspective on how scientific uncertainties, including quantum mechanics, lead to the impossibility of precisely predicting the future. Essentially, this unpredictability is not a representation of lack of knowledge, but an indication that the universe is continually creating new possibilities. Cronin concludes by asserting that if you believe in free will, you have to accept that time is fundamental. In a deterministic universe, there would be no free will, but the fact that we consider ourselves to have free will indicates that time plays a crucial role. This refreshing perspective gives rise to thought-provoking discussions around determinism and non-determinism, which are hoped to enhance understanding of the universe and its mechanics. The podcast continues with Lee Cronin diving further into the core of his assembly theory, expanding on the concept of novelty and its input into assessing levels of complexity within the universe. According to Cronin, novelty symbolizes an innovative configuration, not predicted by the past, but rather discovered in the present. He further asserts that novelty is not purely a result of precedence, but rather a product of genuine novelty, an insight he wants to vindicate experimentally. Delving into the idea of free will and determinism, Cronin expands on Sarah's idea that the universe appears deterministic when looking back at the past and undetermined when venturing into the future. The aspect of unpredictability in the universe is accredited to the breakdown in precision in initial conditions, leading to unexpected novelty and creativity. The concept aligns with his argument that the universe's future can't be restricted by its constraints. Returning to discussions on cell automata, Cronin describes them as novelty miners, and through their complexity presents evidence that the universe is too vast a space to hold itself. He later adds that time is a fundamental resource, and without it, there can't be any free will. In fact, the conception that time is fundamental is also the basis for the existence of free will. Talking about artificial intelligence, Cronin voices his concerns over AI dooming and the popular notion that the evolution of AGI, artificial general intelligence, is on an imminent horizon. He maintains that current understanding of human intelligence is still limited, and therefore the presumption of developing AGI is premature. Despite Cronin's belief that AI doom scenarios are nonsensical, he warns about the urgent need for regulations and the challenges associated with fake data and users introduced by AI. In this section of the podcast, Lee Cronin contemplates on the concept of AI doom, asserting that those propelling these ideas do not possess a clear understanding of knowledge or its epistemology. Cronin highlights a crucial disconnect in assigning probabilities to events with no precedented mechanisms, such as the evolution of AG or anti-gravity discoveries. Cronin critiques the thought process of AI doomers, suggesting that they're creating a virtual reality detached from the actual reality. As per Cronin, the fear of superintelligent systems or AGI is misplaced, stemming from a flawed understanding of intelligence and capabilities. He argues against the notion that AI systems would eventually become smarter or more capable than humans, stressing that our current understanding of human intelligence and decision-making is still limited. Expressing concerns about the potential misuse of AI, Cronin emphasizes the need to properly regulate the field. According to him, overhyping the risks of AI could lead to stringent regulations that might halt progress and control people, which can be dangerous. Exploring the idea of unintended consequences, Cronin concedes that the potential for harm is real. Hence, he agrees with the need to be cautious with the implementation of AI systems. Nevertheless, Cronin deems the AI doomer's approach as unbalanced, noting that it could motivate premature regulation and limit the pursuit of knowledge. Cronin also considers the implications of AI on global politics. He points out that relying on AI for global political decisions might result in more objective, beneficial outcomes than relying on human politicians. Cronin insists on viewing AI as a tool that could be utilized to decrease global conflicts, highlighting its potential in implementing game theory strategies. Overall, while Cronin does acknowledge the potential risks, he urges a more balanced and thorough understanding of AI's abilities and implications. In the dialogue, Cronin expands his discussion on the impact of AI in society, particularly on the idea of globally diffusing advanced military weapons like nuclear weapons. He hypothesizes a simulation that mirrors international politics, asserting that AI can effectively create a virtual nuclear agreement. In this scenario, countries would engage in virtual conflicts, leaving real-world consequences to purely economic setbacks as opposed to mass civilian casualties. Verging into AI's capabilities, Cronin discusses the common misunderstanding about AI's ability to generate novelty. He explains that current AI, including large language models, essentially mine the past information, unable to genuinely produce anything outside their training data or truly predict the future. Cronin poses a challenge of distinguishing between trial and error, and the generation of new knowledge, suggesting that true novelty results from algorithmic leaps we do not yet fully understand. Cronin converses about the idea of a chemical brain, a concept where in a material A gel, in his example, can be engineered to serve as a hybrid reprogrammable hardware. He indicates the potential this could have in crossing domain knowledge and processing vast amounts of information, potentially billions of times cheaper than current methods. He continues to raise important questions about AI's intentionality, reasoning, and capability to produce truly new insights in ways qualitatively different from human intelligences. He expresses skepticism towards the optimistic prospects of AG, artificial general intelligence, arguing that existing iterations of AI lack intentionality and reasoning because these qualities are framed by the humans who program them. Despite his skepticism, Cronin acknowledges the potential for AI to create highly impressive intelligent systems. He sets a condition for being convinced of an AI's superintelligence if it can generate novel ideas from the future that could not have been predictably derived from its past training data. He asserts that human intelligence, at least for now, can mine novelty in ways that AI cannot, which is why humans remain the drivers behind creation and innovation. Cronin delves deeper into the various aspects of assembly theory and its capabilities. He envisions AI as a tool that could help prove that time is a fundamental aspect of existence and that humans are adept at generating novelty to adapt to unexpected environmental changes. Coming to his perspectives on generating novelty in AI, Cronin admits that while AI systems can create useful entities, the novelty of these creations remains to be seen. He posits that true novelty manifests when different causal chains overlap, contributing to future novelty. He thinks human intelligence continually generates novelty, thanks to its ability to mix it up a little, an aspect that current AI technology lacks. Intriguingly, Cronin talks about applying AI to chemistry, specifically developing a transformer mechanism for generating molecules auto-binding to hosts, essentially an end-to-end drug discovery machine. He explains how their system involves creating an electron density model trained on millions of molecules. This model can then generate molecules with 12 heavy atoms, an impressive feat given that it was only trained on up to 9 heavy atoms. Cronin then delves into an interesting discourse about the presence of a superior, creative force within the universe, a topic often associated with the concept of God. He identifies selection as this force, emphasizing that the existence and persistence of things are extraordinary in themselves, and may suggest that everything possible to exist in the present does exist. Additionally, he emphasizes the significant causal consequences of imagination. In his discussions about free will, he suggests that free will might exist at the boundary between the past and the future. He introduces the idea that our imaginations can have tangible consequences on the future, a phenomenon that cannot be predicted by current physics laws. He believes indicates there's a profound power within human imagination that current AI technologies are yet to comprehend. Cronin unfolds his thoughts on the universe's nature, its undecided disposition, and the excitement that comes from each unanswered question, leading to a multitude of new ones. He doesn't dwell on the inevitable end of his personal journey, seeing this as a passing of causal power. From the perspective of posthumous influence, he notes the significance of Isaac Newton, whose ideas continue to shape our understanding of the world long after his demise. His personal aspiration is to leave enticing Easter eggs of his work and ideas woven into the fabric of the future. Discussing why representations of individuals, Cronin exhibits a grounded outlook. He seems to believe that while AI can simulate a person's ideas or actions based on past data, it will fall short in generating the fresh spark of novelty that humans innately provide due to their unpredictability. This is what keeps human interactions exciting and infinitely fascinating for Cronin. Maintaining this thread of thought, Cronin proceeds to define life as a byproduct of selection while also impacting the universe. This mutual interaction, he believes, makes a universe with life fundamentally and physically distinct from a lifeless universe. He envisions that humans in the future might develop a discipline to understand these intricate connections fully, much like his brainchild, assembly theory. His conversation with Lex Fridman ends on a promising note, with Cronin looking forward to future dialogues and carrying on his work. The podcast wraps up with an inspiring quote from Carl Sagan that underscores our progress as a civilization rests on the courage of our questions and the depth of our answers. This quote echoes Cronin's insatiable curiosity and endless pursuit of knowledge.